Okay. So I will tell you this, we're shifting gears a little bit in terms of new terms that I'm going to introduce, but quite often you're going to see similarities with what we've been doing so far. Okay, so there's going to be some converting, there will be some proportions, that still stays, but we're just talking about different terms here. So we have a scale diagram. What is that? A drawing in which measurements are proportionally reduced or enlarged by a constant factor from the original or actual object. Okay. Scale, the ratio of a measurement of a scale diagram to the corresponding measure on the original actual object. Scales can be reduced just like fractions, right? Different units are okay. I'm going to say that here. Different units are okay, but no decimals. Okay, so we don't want decimals, but having two different units, that would be okay. Scale factor. The scale factor is indicated by the letter K. It's similar to a scale, but expressed as a fraction, decimal, or percent. And here's the important part. It has no units. Okay, a scale factor should have no units attached to it whatsoever. Okay. So I'm going to give you essentially the same concept, but in different contexts. Okay. So for a scale, when it comes to pictures, blueprints, model, I will even say maps. You can put maps on top of that. When you're looking at a map, you should be using diagram compared to, right, actual. Right, so the scale on a map, you can see at the bottom 1 to 10,000 or 1 to 1,000,000 or something like that, right? So what it is on the diagram and how much does that represent in on the actual landscape. So this is the scale, okay? When it comes to scale factor, when you have a scale, you can turn it into a scale factor. And what we do is we say the scale factor is equal to the diagram measurement, right, over the actual measurement. Okay. So I basically took this and I stacked it like that to make it a fraction. When we make copies, replicas, or make similar things, right? So we start, for example, with a cup or a can, and Pepsi wants to make a king can, right? A bigger one of the original, like stuff like that. I would use this terminology. I would use new compared to original. It just makes it easier to know where do the numbers go when you think of it that way. And my scale factor is new divided by original. In both instances, they tell us the same thing. Like what is happening is something being enlarged or reduced, but it's more beneficial to use these words when we're dealing in this context and use these words when we're dealing with anything that has to do with pictures, models, and so forth. So for example, if you're in science and you're making a little model of like a parachute or something and you're testing it, right, that'd be the model, but really you're thinking there's that actual big parachute that you're trying to make, but in the meantime you're just using a model for it, right? So that's the scenario there. All right, let's talk a little bit more about scale factors in particular. Is it a reduction or is it an enlargement, right? Remember that the scale factor affects the actual or original, which results in what is the diagram or the new, right? So either we use actual diagram or we use original / new, right? So they kind of they correspond to each other. So when you look at a scale or scale factor, it will tell us what happened to the actual dimension, right? So what happened to the actual or the original? That's what we're always asking ourselves. That's what the scale factor answers, okay? So let's look at a car, for example, a picture of a car. So let's say this is our actual or the original, right? If k is less than 1, right? Or you can say k is less than 100%, that also works. Right? We have a reduction of the original. Of the actual or original. Okay. So some examples, 0.2, 2/3, 65%, right? Any of those scale factors, when you get that, you're just like, okay, this means that the original, right? The original item has been reduced, right? Just looking at the numbers, the results, right? Next, if k is equal to 1, or you could also say k is equal to 100%, there's no change. No change. So we're talking identical copy, right? So there's nothing else we need to know about that, right? Let me zoom in a bit more if I can. And then we have k is greater than 1, or k is greater than 100%, right? That would be an enlargement, right? So we have enlargement of actual / original. Okay. So examples would be 1.2, right? 5/4, 125%. Anything that's either bigger than 1 when you divide it, right? So 5/4 is 1.25, right? It's bigger than 1. So we know that if you compare both of them, an enlargement happened from the original to the new, okay? So you need to know that. I want to make a note right on here, okay? It might be a little crowded here, but I'm trying to be creative here. If you have the original, which is 100%, okay, and you're down to 65% of the original, how much of a reduction happened? If you go from 100 down to 65, 35% reduction, right? So some students say, oh, there's a 65% reduction. That's not correct. When you come up with a scale factor of 65, it means that from the original, which is 100, you have 65% left, right? So 35% reduction. So if k is equal to 65%, comma, then 100 minus 65%, right, would be 35% reduction. Sorry about that. That's very crowded, isn't it? And I'm going to highlight that. Right? If k happens to be 65, if k is 20%, then there's an 80% reduction, right? So you always have to think, what happened to 100%, right? Oh, there was a 35% reduction to get to 65 and so forth. And here, if k is 125%, then what happened? Oops. You're not recording this, Mr. Dirksen. There we go. You're out of frame. If K says 125, how much of an enlargement happened? 25. Right? Then 125 minus 100, so that's 25% enlargement. How do we know it's an enlargement? Well, because K is over 100%, so that we knew. So there it is. So I'm going to do that. I'm going to highlight that as well. Boom. So now we know. Now we know what. Not quite. We're going to practice, but in theory, now we've covered which words do we use when, and what is a scale versus a scale factor. How do we know what happened to the original? Well, just look at the actual value of your scale factor. And we can also answer by how much something has been enlarged or reduced. All in one page, guys. Okay. So let's practice this a little bit further. So here we go. Come with me to the next page, 22. So just plain and simple working with a scale. How do you know this is a scale? Right? A number, colon, another number. Different units, that's all fine. Okay? What is it asking now? State the scale factor, right? Scale factor used. And I want it as a fraction, as a decimal, and as a percentage. We have to say no units, right? That's important. You should automatically know, okay, in fact, on your study sheet, make sure next to scale factor, always say there should be no units there. There we go. So A, this is what you do, right? We're just going to go 1 centimeter over 50 meters. Can't have that. But I can't cancel those out, can I? Not yet. So we do some converting here. Convert. What do you want to do? Centimeters to meters or meters to centimeters? I always go from the bigger unit to the smaller unit. That's what I tend to do. So 50 meters times 1 meter, 100 centimeters. Cancel, cancel. Right? So that gives me 5,000 centimeters. Perfect. So I'm just going to do that on the side like that, right? I love it when you do that, guys. Like, do some work on the side. Just show me somewhere on the side. This is where I'm doing that. I don't mind it. I'm like, okay, good, good. Okay, let's continue with our work. So we can now rewrite this in centimeters, right? And now we can cancel these out. And so our scale factor is 1 over 5,000. Perfect. Simplifying fractions, guys, not really a problem for us. Like, I'm not going to make you simplify fractions. I'll actually show you how the calculator does that for you. It's pretty sweet. But you can't tell anybody that I showed you how to do that, right? Because in grade 12, you might have a teacher that says, hey, I want you to simplify fractions. You just know which buttons to press, all right? So here we go. Fraction. Let's get the decimal, okay? So I'm going to say this. K is 1 over 5,000, comma, decimal. Try this, please. Use your calculators. Good luck with this one. If you're taking chemistry or physics, your scientific notation is going to come in here. 1 divided by 5,000, what's that? Oops. I'm just going to write down 2, Mrs. Dirksen, because it's 2, right? I'm just going to ignore that. You can't, and you have to. So here's the cool trick about that. It's saying 2 times 10 to the power of -4, which means the decimal place. So 2e to the -4 is really saying 2 times 10 to the -4. Okay, so what that is saying, right, is if the decimal is right here, we're going to move forward 4 spots. 1, 2, 3, 4. Right there. And then the values that you've made, you just fill those in with zeros. Right? So that's what happens there. But let's say you don't want to do this. I don't blame you. You can just go like this. Watch. I go plus 1 or whatever you want, but I go plus 1. You got to ignore the 1, right? Because you added that just to force it to look like a decimal. Right? So now you know it's 0.0002. Okay, that's just a trick. That's just a trick. So we know this is 0.0002 now. It's finite, so I want you to have all decimals there. And percent, I can just take that one, right? That answer that I had up here and just multiply that by 100. And there we go, 0.02%. B, how much has the original been reduced? I already gave it away that it's a reduction. We knew it already. It's less than 1. It's less than 100. It's a given. So we'll say this. Reduced by I'm going to go percentage here. I like percentages when it comes to stating this answer. And so that would be 99.98%. Okay. So from the original, right? From the original compared, right? If you start with the original to the new, right? You reduced it by 99.98%. Or if this is, right? If you're talking diagram actual, the actual object, maybe it's a big ship, and you're trying to fit that on a tiny little, right? Space, you reduce it by 99.98%. Okay. All right, let's keep going here. Let's say you have two objects actually given to you, and there's a whole bunch of information there. And it's asking you, what's the scale used to produce the diagram? And notice, I tell you that this is the diagram, and that's the actual. That's very important to note, okay? I don't always do it in that order. Sometimes I flip it on purpose, right? Just make sure you read that. So scale. So I'm going to answer A here. Scale, it's asking me what terminology should I use here, Mr. Dirksen? Well, why are we going to stick with diagram and actual if it's already stated, right? So you don't even have to guess there. But you need to state it like this, okay? And you need to find corresponding dimensions. So which two correspond? These two correspond, right? The height of the truck corresponds with this height. But we have this unknown, so not good, right? So we're going to shift here. These two correspond, and I have both of them, so that's the one I'm going to use. And this is diagram, so I'm going to go 14 inches and 25 feet on the other side. Done. Right? This is the answer. Different units are okay. So we're done. No decimals though. So if you had 2.5 on this side, you would multiply both sides by 10. All right? Multiply both sides by 10 to get rid of the 0.5 and so forth. B, the scale factor. I'm just going to make sure you understand this. The length, we use the length of the diagram, and we compared it to the length of the actual truck. Okay, so this could be a toy truck and the actual truck, right? Or it could be on a picture. so forth. So just to know, we compared the lengths. Okay, B. I'm going to do that here. Scale factor. I'm just going to use what I already know here. 14 inches. Oh boy, we're going to have to do converting. No problem, right? I'm going to do some conversions here. I'm going to convert my 25 feet, knowing that 1 foot has 12 inches. Do I need to square anything? Cube anything? No. Okay. 25 times 12. I was actually very impressed. A lot of you caught that I needed to square here. I need to write like your rates before you cancel things out, like on the AC I'm talking. So way to go, guys. So that would be 300 inches. I'm going to do this on the side here. Okay? So I bring this back to my calculation. So I'm going to go 14 inches over 300 inches. And then I cancel out. And here's the beauty of the calculator. If you want to reduce that fraction, follow my steps here. I go 14 divided by 300. They're both even, so you can reduce this, right? For sure. So you got to go math. You press this, and then you go math. And the first selection is already highlighted, so you just hit enter. And then enter one more time. And there's your reduced fraction. You wish you had that in IPR, right? 7 over 150. I'm going to say this, you will not lose marks if you don't reduce, okay? So let's just put it that way. So this is it. This is your scale factor. Let's state it as a decimal and percentage, just because I want you to be familiar with that. Next, in grade 12, you're going to do probability. There's a lot of fraction, decimal, percent stuff. So if we divide these two, watch what I'm going to do here. This is going to be maybe a little new to you. I'm going to round. If you round this to 2 decimals, it actually turns out to be 0.05, correct? But you can't now say it's 5%. That would be wrong. So what you need to do is you need to go off of what's on your calculator and multiply it by 100 to get 4.67%. So you basically always go back to your fraction, and that's how you state. Okay? So it went from this to this, and then I went from this to that. It's a little nuance, right? It's a little, but that's grade 12 provincial standards. This is how you do it. You don't go from fraction to decimal and just turn that decimal that you rounded to a percentage. That'd be wrong. You got to go fraction to decimal, and go back to your fraction and turn that into a percentage and round it to 2 decimals again. Okay. So much stuff to remember, right? Okay. What else does it ask? What kind of reduction happened here? We know it's a reduction. It has been reduced by about 95%, right? Just to make it clear. See? Determine the height of the truck on the diagram. What is going on here? We want this. We want that. How do I start? Remember what I told you before when we started this unit? You have a rate that is true. Remember? 80 kilometers per hour stays like that. This is also a rate technically. It's something that is true. Every single dimension from this has been altered by that scale factor to produce that diagram. Okay, so this is always true. This is always true, right? So which one do you want to use? It's up to you. Okay, I'm going to use this one. In this particular case, I'm going to use 14 inches over 25 feet. Okay. This is diagram and this is actual. So I know the height of the actual, which is right here. So that 10 feet, I'm going to match feet with feet. In this case, you just got to match the units. And you're going to say this is the height in inches is going to be calculated by just performing a cross multiplication and division, right? So here we go. H is cross. This is like grade 9. Remember doing scale factors in grade 9? Maybe it's been too long, but you did this in grade 9. 10 times 14 divided by 25. And your answer is going to be in inches. $5.6. Do I have enough space for you? Please follow me here. I like or. I like to give you another option. I use this. This is not really a scale factor, is it? Not. This would not be appropriate to state that as a scale factor, so we have to do some work. But if you want to use that to solve any unknown, go for it. You can use it. But let's say you're like, well, I want to use the 7 over 150. Okay, sure. 7 over 150. No units, right? And you're like, well, where should the 10 go? Should it go on top? Should it go bottom? What do you always know when I come up with my scale factor? It's always diagram on top and actual at the bottom. So that should guide you to know where to plug in numbers. Because if the 10 had been here, right, that means that you have the height of the diagram, but this would be unknown, in which case you put the 10 there, right? So in this case, the 10 is the actual height. So we're going to put 10 what? Feet. So this is height. What would be my height here? What units would it be in if I had set it up like this? The only units available here is in feet, right? So your answer here will be in feet. So you might have to do some converting later. So watch this. 10, right? 10 times 7 divided by 150. So that's 70 divided by 150. That's 0.466, and that repeats feet. But watch this. Times 1 foot has 12 inches. Cancel, cancel. So you just multiply that by 12. Oops, there it is, 5.6 inches. So I need you to see the connection here. I need you to see that, oh, everything is connected. I just have to be careful, right, how I do it. Okay. D, by how much has the actual truck been reduced? And I'm going to try to answer that here. Or, do you have some space down here? You guys have space? Yeah. Okay, let's do it. I'm going to cut this here. I'm going to cut this here. And hope for the best, right? D, reduction of something percent, right? So I will just go over here and I'm just going to go 100% minus 4.67%. And so that's 95.33%. Right? So I'm going to put that in this bracket, 95.33%. All right. Shake it off a little bit. I want you to try this right away. I'd like you to try it right away, not after class. Give it a try right away. So I'm gonna ask you to just do this first question, the cell question on page 23. If you're done that, you can go ahead and try the bottom one. But for now, try to use what you already know. Make sure you use a pencil. Try to use what you know to come up with a scale factor, and so forth, right? Just give it a try. There you go. So that the diameter of the animal cell is represented by the scale diagram, right? But this scale diagram is actually, there's that key word, right? I'm giving away, right? Is actually, it didn't have to say that, right? It could have just said that the scale, the animal cell is this, but then you have your diagram here, right? So that's actual, obviously, actual, and this is diagram. Right off the bat, we know that we need to make that distinction. I'm going to use those words here. So for A, state the scale used for the diagram. Well, I have the diameter here, and I have the diameter of the actual. I have both of the diameters, so I can just go diameter of diagram and compare it to the diameter of actual. That's really what I'm trying to say when I gave you that diagram actual thing. It's like corresponding measurements. Okay, you can't just take two random measurements, right? So here we go. The diagram has 4.75 centimeters, and you compare that to 0.25 millimeters. Is that okay for a scale? Units, different units is all right, but no decimals. Right? So what we do with it is just count the greatest number of decimals you find. So in this case, it's 2, right, for both of them. So I'm just going to multiply this by 100. Okay? So that actually turns out to be 475 centimeters and 25 millimeters. Right? No decimals, I'll say. So if you didn't catch that, it's not the biggest deal. It's not going to affect what we are doing after, right? It's still going to be correct. But this is the standard, so this is what we want. Okay. Perfect. Now we have the scale. Now the scale factor, which is K, right? No units. So scale factor, I'm just going to take the first number over the second number. And we know that from the original, the actual, an enlargement happened, right? To see the cell on a piece of paper, right? Like you would have to enlarge it. There's no doubt about that. Let's convert. I'm going to go 475. And it's okay if you don't show that on the side. If you just, it just shows up. These ones I'm pretty okay with, right? So 1 meter has 100 centimeters. Sorry. I'm hungry. What can I say? Let's try this again. 1 centimeter has 10 millimeters, right? That's better. And so that's 4,750 millimeters. I'm going to do this on the side like that. Okay, so I rewrite this like this. Cancel. Perfect. And what do you get when you divide these? You actually get a whole number, right? 190. I should double check this. You're awfully quiet today. I don't know if I'm getting everything wrong here. It's actually 190 exactly. So it's 190 as a decimal, little figure, right? And you multiply that by 100, that's 19,000%. Okay. So there you answered scale factor. We're good? Okay. C. Is this an enlargement or reduction of the actual? Explain, and by how much? This is an enlargement of the original, comma, since K is greater than 100%. You can absolutely use that. Just K is greater. If you want to write out in words, go for it. But K is greater than 100%. And then we'll say enlarged by some percentage. Okay. So the way we do this one, if you want to do the calculation on the side, right, we go like this. Right, by 18,900%. So you take whatever you got up to, subtract 100 from it, right? Basically, you're finding how much above 100 did you go, right? So this is the calculation here on the side, if you will. D. If the nucleus has an actual diameter of 0.12 millimeters, determine the diameter of the nucleus in the diagram. It doesn't tell us in which units, so we're just gonna, Mr. Dirksen, you didn't tell me, so I'll just give you an answer, right? Here you go. I'm gonna use, you can use this one, you can use that one if you'd like. It's up to you. Mr. Dirksen, can I use that one? Technically, yes, that's 190 over 1, if you want to put it that way. It's still a fraction, right? So it's up to you. They're technically all the same. If you're working and answering missing dimensions, you go with whatever you like. So I'm going to use this one here. I'm going to go 475 centimeters over 25 millimeters. And that equals to, where would I put this one? Bottom, because this is the actual, right? And we always know K is always diagram over actual, right? That's just a reminder that's on your study sheet, right? So we know the actual, so that goes down here. Another giveaway is the units, right? Millimeters, right? Both are millimeters for the actual. And so this would be the diameter in centimeters. And so to find D, we just cross multiply and divide. So watch how the units are going to cancel, right? I'd like you to still know that. Right? Millimeters cancel with millimeters, and you're left with centimeters. And I get 2.28 centimeters. .28 centimeters. Okay. I want to show you one more thing, but I will already tell you the homework is 23 to 24. Right, so this bottom question here and the back side of this. Okay, I will post that. So make sure you highlight that. Okay, to not forget. Mr. Dirksen, at the bottom of this page it says textbook. Should I do that? Only if you want to. If you feel like you need a bit more practice than this, you go to the textbook, and maybe some of you have been eager to open that thing, right? You go for it. I'm going to skip some. Skip. I'm going to take you to 27. Scale diagrams. For scale diagram steps, convert actual dimensions using scale. Okay. You can use the shortcut formula to get the diagram dimension. You just go scale factor times the actual dimension, and that's how you get it. Okay. Second step, if you're asked to draw it, you draw the object using conversions in right, in step 1, and then label diagram using actual dimensions. Okay. So this would be a graphing scenario. Okay. So here we go. The dimensions of a room would be this. So this is the actual room. Okay. So a room measures 12 meters by 8.6 meters. And then you have a scale. Okay. This is your scale. I'm going to turn that into a scale factor real quick. I'm going to go 1 centimeter over 2.2 meters. This is the equivalent of 1 centimeter over, this could be converted to centimeters by just multiplying it by 100. So that's 220 centimeters. Cancel. So there you have it. Now you have your scale factor. 1 over 220. It's not the only way of doing it, but it's one way of doing it. So I came up with a scale factor. Now I'm going to do this. For length of the diagram, I'm just going to go scale factor times 12 meters. And you're going to figure that out. Then you're going to go, the width of the diagram is 1 over 220 times 8.6 meters. And you're going to come up with an answer there. So let's go ahead and do that. So basically what you do is 1 times 12, which is 12, divided by 220. Right? So that's 0.054 meters. I'm just going to multiply it by 1 meter has 100 centimeters. So I basically just multiply this by 100. So that's 5.45 centimeters. Very important. You do the same thing with the other one. 8.6 divided by 220. That's 0.039 meters. I will go ahead and say that 1 meter has 100 centimeters. Why am I turning this into centimeters? Because I'm gonna graph it, and so centimeters is much easier than 0.039 of a meter, right, to graph. So this is 3.91 centimeters. And if you have a ruler, this is the one time on the test, if you have to do this, I often provide you with grid paper on it, like right on the piece of paper, so you can just assume that one box is half a centimeter. Like I'll tell you that, but I prefer you having a ruler. Okay, so all you need to do is you need to draw a box that is 5.45 centimeters, right? So you go 5.5, almost 5.5, not quite. And then the width is 3.9, right? So you go right there. So 3.9 is right about there. And then just try to replicate that. And the way I do these is I cut out a piece of paper that measures that and then just put it over your answer. And if it matches, then you're good to go. If you're off by a little bit, we're not going to sweat it, right? Like by a little bit. So what you do here, watch this. This is the tricky part. I'm going to take off marks if you don't do this. You got to label it with the actual dimensions. So this is 12 meters, and this is 8.6 meters. Okay, label, it says there, actual dimensions. if you want to say on the like this in brackets, if you want to say 3.91 centimeters, or in brackets 5.45 centimeters, I'm okay with that. Okay? But if you do a scale diagram, we require you to have the actual dimensions on it. So it's almost like saying, hey, this is what it would look like on a piece of paper if we reduced it, right? So there we go. So that's one question there before you fall asleep. I just want to show you one. Yeah, I want you to go and try on page 31, question 4. I'm going to write that down. Only one. I'm going to ask you to be able to try one like that by tomorrow. And that's it. Sorry, guys. I think it went a little too long today.